All right, let's talk about applications of the law of cosines. So some application problems where we have to use law of cosines. All right, so this first problem says to estimate the length of a lake, Caleb starts at one end of the lake and walks 95 meters. He then turns and heads down a new path 120 degrees to his original path and walks 87 meters until he arrives at the other end of the lake. About how long is the lake? Round to the nearest tenth. So yeah, let's draw a diagram here. So we have some kind of lake here. All right, and then Caleb starts at one end of the lake and he walks 95 meters. I'm going to assume that it's sort of he's trying to get to the other side of the lake, so he's not going to be walking off this way somewhere. So you could have also drawn it above here, but I'm going to draw it sort of like below, like this, okay? And then he turns and heads down a new path 120 degrees until he gets to the opposite end of the lake. All right, I'm a little bit off there, but that's all right. We'll say the lake's just a little bit longer. How about that? Okay. So this is 120 degrees. This is not drawn to scale by any means. And this was 87 meters. And this is 95 meters. Definitely not to scale, but that's all right. It's still going to work for us here. So we want to figure out what is the length of this lake here. Now, law of cosines, I might just write one of the formulas up here. A squared equals b squared plus c squared minus 2bc cosine angle A, all right? And you can kind of switch around the letters to get two other versions of the formula, but I'm just going to leave that one up there and kind of use it to think about this. And since I'm using, I use the version that has angle A here, I'm going to go ahead and make this my angle A because I know I'm going to have to use that in the formula. But really, you could label this anyway. You could do, A, B, and C anywhere. I would suggest using A, B, and C since that's what the formulas use, but you don't have to use those letters, but it makes it a lot easier. All right, so that means the length of the lake is little a here, and then side B is 87, side C is the 95 here, right? It's opposite, okay? Angle C is opposite side C, etc. So let's write out that, well, I have the formula up here, so I might just go ahead and fill it in right here. So a squared, well, we don't know a. B is 87. C is 95. And then those also go in these two spots. And then angle A is 120 degrees. So now we just go ahead and simplify this side. There's different ways you could do this. I try to not put decimals in until the very end because we get a nice precise answer that way. So I'm going to go ahead and just, so we'll go 87 squared plus 95 squared. That equals 16,594. And then let me multiply those three numbers together. 2 times 87 times 95, 16,530. All right. Now, just be careful here. Very common error that I see. People want to like subtract these two numbers. You can't do that because this has to get multiplied by the cosine 120 first, right? PEMDAS. What I would just do at this point is take the square root of both sides and then go ahead. We'll just put this into the calculator, and that'll give us our approximate answer. All right. So let's do square root. 16,594 minus 16,530 cosine 120. Make sure your calculator is in degree mode. All right, so about 157.7. And this would be meters. So that is the approximate distance of the lake. Okay, so it's about, I'll go ahead and box in the approximately equals also there. All right, there we go. Okay, so that's that. This is a your turn here, but I might kind of help out with the diagram on this one. Its description is a little can be a little confusing here. So it says 3 boats are at sea, Jenny 1, Jenny 2, and Jenny 3. The crew of J1, meaning Jenny 1, can see both J2 and J3. The angle at J1 between the two lines of sight is 45 degrees. Okay, hang on. Let me start drawing this out. This is getting a little overwhelming here. So I like to see the visual as I'm reading it. So we have 3 boats, J1, J2, J3. I really have no idea where they are. I'm just going to place them. I might have to, erase as I go along here. So the angle at J1 between the two lines of sight is 45 degrees. So meaning like from here to here. Well, that I just kind of got lucky there. And this does roughly look like 45 degrees. But, you can always erase and fix that. It doesn't have to be perfect, right? These diagrams don't have to be perfect. The distance from J1 to J2 is 2 miles. And the distance from J1 to J3 is 4 miles. How far apart are J2 and J3? So we're looking, this is like our unknown here. So I'm going to let you guys do the rest. Remember, use those. I would probably label these A, B, and C also. So that's what I'll be doing first as I show my answers. But go ahead and do the rest of number 1 and number 2. Okay, so on this one, I should have gotten 2.9 miles. That one's pretty similar in the process here to the example I did earlier. Number 2 was a little bit more involved. You had to find all 3 angles. So I just picked angle A first, but you could have picked any one to find first. The formula would have looked a little bit different. Yeah, if you don't know those formulas, you can Google that, what the different law of cosines formulas are. And then just plugged in what I knew. And then I had to simplify both sides. And you get to this point where, now again, the big temptation right here is people subtract those 2 numbers. You would not do that. You can't do that. You'd be violating PEMDAS. You just take this away from both sides, and you're left with negative 380,950 cosine A, and then you divide both sides by that to get rid of that number. And then you get this, before I had the, inverse cosines there, you get that. And then you take the inverse cosine of both sides, and yeah, you get about 85.1 degrees. What I like to do to find like the second unknown in these kind of problems is use law of sines. It's a little simpler than the law of cosines. So since I had enough to do that, in order to use law of sines, you need an angle given, and then you need to know an angle and its opposite side, which we know now. We have angle A and we have side A. So now then I can use law of sines. So I did that. If you're not familiar with that process, watch my law of sines video. All right, so there's that. Went through that and got 52.7. And then to get the third angle, once I had A and B, I just took those 2 away from 180 to get the third angle, because that's how many degrees are in a triangle.